Lecture 19, Introduction of Differential Calculus. Now, differentiation. So as you know, the derivative play a very important role, or we say the fundamental tool of the calculus. So the concept of derivative is the core of calculus and modern mathematics. And the definition of the derivative or say differentiation can be approached in the two different ways. We can say the geometrical approach and physical. When we say the geometrical, so we say the slope of the curve, and in physical we say the rate of change. So what is derivative? So we can say a derivative measure the sensitivity to change of one quantity, and that quantity dependent variable we can say, to another quantity, that is the independent variable. Means we can evaluate the rate of change of dependent variable with respect to independent variable. So suppose we have a function, let y is equal to fx. Here y is what? Dependent variable, and that x is what? Independent variable, right? So we take our function y is equal to fx, be a differentiable function, we can say, on the interval a b, then d upon dx, that is the operator of differential, on fx, or sometime we write f dash x is what? Is limit h tends to 0 f x plus h minus fx upon h. This is what is the fourth principle of the differentiation, and this is what? This is known as derivative, or sometimes we say differentiation of fx. So here we have to note that the derivative of the function, we say at a point, suppose we say x is equal to c, is a slope of a tangent, slope of the tangent to the curve y equal to fx at the point c. That is, suppose we are quadrant and we have a curve, that is y is equal to fx. This is a fx curve. So if we take a point x is equal to c here, so at that point if we draw a tangent, so this shows what? This is the slope of that curve, and this is what? This is the derivative at that point. So we can say sometime the derivative is also represent the slope of the tangent at particular point. Now successive differentiation. So what is successive differentiation? It's a process of finding the differential coefficient of a function again and again is called successive differentiation. Suppose we have a function y is equal to fx, we have differential function, and so we write the first derivative, or we write d upon dx of fx, or sometime we write f dash x or d of fx, that d is represent the differentiation, or y dash. So this is the first derivative of fx with respect to x. So similarly we can find the second derivative of that function, two time differentiation, we write f double dash d square of fx. Here d square means the two time derivative, or we can write just y double dash. So this is the second derivative. Similarly we write the third derivative, and so on, we write the nth derivative. So when we do in the way, we write the first derivative, second derivative, third derivative successively. By the help of these derivatives we can find the nth derivative. So here you have to remember that the nth derivative, you represent f, that is not the power, this is mean the nth derivative, or dn power d power n, it means the nth derivative of function, or sometime we write y suffix n, that n means this is the represent the nth derivative of fx with respect to x. Now we discuss some standard function, how we find the nth derivative of some standard function. So we find the nth derivative or nth order differential coefficient of e की power ax plus b. So here we have given y is equal to e power ax plus b. So first we take the derivative, first derivative. So differentiate that function with respect to x. So we can write y1, or you also write d of y. So what's the derivative of that function? As you know, a e की power ax plus b. Then Again you take the second derivative, so we take again differentiation with respect to x of that function. So we write d square of y, or you just write y2. So here what we write, a square e power ax plus b. Then again take the differentiation with respect to x of that function. So we write d cube of y, or we write y3 is what? Again we get a, so it is a3 e power ax plus b. And if we do in the similar manner, then by the help of these three differentiation we can write the nth derivative. How? Successively we observe that in the first term we get a and the same function, a square and the same function. In second derivative, in third derivative we get a cube and the same function. And if we do the same process for the nth term, or the process till go to nth time derivative, so what we get, you can guess, it is a power n e ax plus b. So we can say, if we take the n time differentiation of e power ax plus b, so we get a power n e ax plus b. So this is the nth derivative of that function. Now n is anything, it can be 1, 2, 3 and so on. Now how to find the nth derivative or a nth order differential coefficient of the function ax plus b whole power m. Here m is always greater than n. So here we have given y is equal to ax plus b power m. So first we take the first derivative. I'm writing directly y1. y1 means the one time derivative. So what is the derivative of that function? So we write m ax plus b whole power m minus 1 and into ax, so we get into a. So here we get m a ax plus b power m minus 1. Now take the second derivative, that is d square of y, or we can say y2. So we take the derivative of that function. Again we get ma. Now the derivative of that is what? M minus 1 ax plus b power m minus 2. Now into a. On simplify we can write a square m minus 1 ax plus b power m minus 2. Now take the third derivative also, y3. So what we get? Again we take the derivative of that term. So we get m minus 1 a square and a, sorry, that is m minus 2 ax plus b power m minus 3 into derivative of that is a. So we can write, on simplify, a cube m minus 1 m minus 2 ax plus b power m minus 3. So here you observe that this is y3. Now successively you can write the nth derivative, because the first derivative, when you take the first derivative we get ma ax power m minus 1. When we take the second derivative, so we get a square m minus 1 and ax plus b power m minus 2. When we take the third derivative, so we observe a cube m minus 1 m minus 2 and ax plus b power m minus 3. So in the similar way, if we take the nth derivative, that is n time derivative of that function y, so you can see that we can write what? A power n, because we, in third derivative we get a cube, second derivative we get a square, right? and in first derivative we get a only. So when we take the nth derivative, we write a power n m m minus 1 m minus 2, and the term is expanding because we take the when we take the third derivative, so the term is expanding m minus 1 m minus 2 and so on, m minus 2, and in second derivative it is expand only m minus 1. So if we take the nth derivative, so here it will be expand up to m minus n minus 1. Here we get 3, so we expand it to up to 2. So when we take the nth derivative, so it will be expand up to n minus 1 into ax plus b power m minus, when we take the third derivative, so we write m minus 3. When we take the second derivative, we write the power m minus 2, and when we take the nth derivative, so we write m minus n. So here you can write, by the simplifier you can write a power n, and this is what this is, write m minus 1 m minus 2 up to m minus n plus 1 ax plus b power m minus n. So here you see that this is what, this is the nth derivative of that function ax plus b power m. Or you can also write that term or simplify that term, or you can write, if that m is what, positive, so we can write factorial, it becomes the factorial m upon m minus n factorial into a power n into ax plus b power m minus n, if what, m is positive. You have to remember here, if m is positive. So this is what, this is the nth derivative of that function. Now take the, find the nth derivative or differential coefficient of function log ax plus b. So how we find the nth derivative of that function? In the similar, in the previous example, we take the first derivative. So here we given let y is equal to log ax plus b. This is a function. So first we write dy1, means this is what, this is the first derivative, or we can say dy, first derivative. So what's the derivative of log ax plus b? So it is 1 upon ax plus b into the derivative of ax plus b is a. So here you can write a into ax plus b power minus 1. Now take the second derivative y2. This is what? This is the two-time differentiation of function. So what's the derivative of that function? So we write minus 1 ax plus b power minus 2. A is already there, and when we differentiate that term, so we get a square. Now take the third derivative y3. This is what? So we get a cube minus 1 minus 2 ax plus b power minus 3, right? And the similar way we can find the y4 also. This is the fourth derivative. This is what, a, we get a4 minus 1 minus 2 minus 3 ax plus b power minus 4. So we take the fourth derivative, and by the help of these derivatives, successive differentiation, we can write the nth derivative. How? You observe that when we take the second derivative, we get a square. When we take the third derivative, we get a cube. When we take the fourth derivative, we get a4. So when we take the nth derivative, so what we get? First we get a power n, and we get, when we take the derivative one time, we get minus 1. When we take the second derivative y cube, we get minus 1. minus 2. So here we get two negative signs. When we take the fourth derivative, we get three negative signs. So when we take the nth derivative, so we can say we get minus 1 power n minus 1. Okay, and here you see that 1, 2, 3 when we take the fourth derivative, and when we take the third three derivative, we get 1 and 2. So in the similar way, when we take the fifth derivative, we get 1, 2, 3, 4. So we can write the factorial n minus 1 into ax plus b power minus n. Why minus n? Because when we take this fourth derivative, we get power minus 4. When we take third derivative, we get minus 3. So successively you can write, when we take the nth derivative, you write ax plus b power minus n. Or you can, or simplify, you can write yn is equal to a power n minus 1 power n minus 1 factorial n minus 1 upon ax plus b power n. So this is what? This is the nth derivative of that function. So by the help of that, if we ask, can you write the nth derivative of log 3x plus 2? So by the help of that formula, you can write directly what here is, what is 3. So you write 3 power n into minus 1 power n minus 1 into factorial n minus 1 divided by 3x plus 2 power n. So in that way you can find the nth derivative, or if we say you find the 100th derivative of that particular function. So by that recursive formula, you can write the nth term derivative or any time on the derivative. Now what is the nth order differential coefficient of that particular function? 1 upon ax plus b, when x is not equal to minus b upon a. So in that case, as in previous example, you can also find the nth derivative of that function. How? First you find we have given the function y is equal to 1 upon ax plus b. So you write that function ax plus b power minus 1, or we can say ax plus b inverse. So first you take the first derivative y1, so we get minus 1 ax plus b power minus 2 into a. When you take the second derivative, so you get minus 1 minus 2 ax plus b power minus 3 into a square. And in similar way, you can write y3, which is minus 1. y3 is what? Third derivative, minus 1 minus 2 minus 3 ax plus b power minus 4 a cube. And successively, by the help of these three differentiation, you can write the nth derivative. So what we get when we take the 3 time derivative, we get 3 negative signs. 2 time we get 2 negative signs. So first we write, when we take the n time derivative, so we can write minus 1 power n. Here a power is 3 when we take third time derivative, a square when we take 2 time derivative. So when we take the n time derivative, what we get? A power n and ax plus b power. Here you note that when we take the 2 time derivative, we get the ax plus b power is minus 3. Third time derivative, we get ax plus b power minus 4. So it is, when we take n time, so we write n minus, sorry, here we write minus n plus 1. So this is the n time derivative of that particular function. So now find the nth order differential coefficient of that particular function sine ax plus b. So it's a very important function, because there is a little bit confusion in when we write the nth derivative of that function. So here we discuss, now we have given what? Y is equal to sine ax plus b. Now we write the first derivative, that is y1 is what? First derivative is what? A cos ax plus b. Now you see here, when we take the second derivative, we again get a sine term. When we take the third derivative, we get a cos term. So it is very difficult to write the nth term by seeing the successive differentiations. So in that case, sine or cos, in that case, what we do, we convert that at that stage, and means y1, we convert that cos into sine, and we can convert by the help of trigonometrical formulae. You have to remember that. And what is, you can write pi by 2 90 plus ax plus b. So you have to remember sine 90 plus theta is what? Cos theta. So pi by 2 plus ax plus b. Now take the second derivative of that function. So again, what we get? The differentiation of sine pi by 2 plus ax plus b is what? Cos pi by 2 plus ax plus b, and a is already there, and when we take the derivative of that function, we get again a, so we get a square. Now we get cos, again you convert that cos into sine, so you write a square sine pi by 2 plus theta. Now theta is what? This one, means pi by 2 plus ax plus b. So here you observe that we get a square sine, and this pi by 2 plus pi by 2, you can write 2 pi by 2 plus ax plus b. This is what? This is second derivative. Now take the third derivative of that function. So what we get? Again, the derivative of sine is what? Cos. So you write cos 2 pi by 2 plus ax plus b into a, and a square is already there, so we write a cube. Again you convert that cos into sine, so you write a cube sine, again pi by 2 plus theta, that is 2 pi by 2 plus ax plus b. So here you can write a cube sine, this become 3 pi by 2 plus ax plus b. Now this is what? Y3. Now y3 is there, y2 is there, and this is y1. So successively you can write the recursive formula, that is y nth derivative is what? Yn. So what you write? When we take the third derivative, we get a cube. So when we take the nth derivative, we get a n, and sine here is 3. So we write n pi by 2 plus ax plus b. So this is the recursive formula, or we can say nth derivative of that particular function. So now take one more example. Find the nth order differential coefficient of the function y is equal to sine 2x into sine 4x. So here you have given a function sine 2x into sine 4x. So sine 2x into sine 4x. So if you multiply and divide by 2 that term, so we write 1 by 2 2 sine 2x into sine 4x. So apply the formula of 2 sine A sine B. So what is that formula? So we write 1 by 2 is there. So what we write? Cos 2x minus 4, that is 2x minus cos A plus B, that is cos 6x. Right? Now this is what? This is y. Now you directly take that differentiation, nth differentiation, or we say n time differentiation of given function, that is this one. So you write the nth derivative, or you just write yn of 1 by 2 cos 2x minus cos 6x. So you just write what? 1 by 2 and take that derivative. So you write nth derivative of cos 2x minus nth derivative of cos 6x. And if you remember how we find the nth derivative of sine ax plus b, similarly find the nth derivative of cos 2x and cos 6x. So I'm writing directly the nth derivative of cos 2x is 2 power n cos 2x plus n pi by 2, and similarly we get minus 6 power n cos 6x plus n pi by 2. So in that way you can find the nth derivative of such type of function by using the previously defined functions. Thank you. Continue to the next lecture.